Hello friends, welcome to Evan Academy. In the last lecture we have started the discussion on the conformal transformation. Also we have seen two questions on this topic. Okay, so in this particular lecture we will discuss further questions on this topic. Okay, so let's start. So in the last lecture we have discussed in detail about the conformal transformation. So what is a conformal transformation is basically it is a transformation from a z plane to a neta plane, okay, using a function that is given by neta is equal to z to the power n. So what we have seen in the last lecture is that suppose we have two planes, okay, so this is z plane and this is a neta plane. Okay, so we are doing the transformation from the z plane to the neta plane. So suppose there is a point z in z plane, so its image will be f of z. So this f of z is basically neta. So this function is being governed using the expression neta is equal to z to the power n, where n is given by pi by 2 upon half of angle between the boundaries, theta 1 plus theta 2. And what is this theta 1 and theta 2? Theta 1 is the angle of inclination of the boundary 1 with the horizontal. Okay, so this is our boundary 1 and this is boundary 2. So theta 1 is the angle of inclination of boundary 1 with the horizontal, and theta 2 is the angle of inclination of boundary 2 with the horizontal. So in the transformed that is this neta plane, so we have this phi 1 and phi 2. Suppose this is the transformed boundary, okay, in the neta plane. So this is phi 1 and this is phi 2. Okay, and suppose there is a point a comma 0. Okay, so this get further transformed into a to the power n comma 0, and this is n times of theta 1 and n theta 2. So this we have already discussed in detail in the last lecture. This is n theta 2. Okay, so because how this n theta 1 and a to the power n comes, so we have neta is equal to z to the power n. So let us take r e to the power I theta to power n. So this is r n e to the power n theta. So this is capital R e to the power I of phi n. So r is equal to r to the power n, or phi is equal to n theta. So from here this comes into picture. Okay, so this we have discussed in detail. Also we have seen that there is no change in the strength. Suppose there is a source of strength plus m, so this will not get changed here, okay, on doing the conformal transformation. So whatever transformation we are doing, so the strength of the source, sink and the doublet remains the same. It is independent of the conformal transformation. Okay, so let us discuss these questions. तो देखो क्या दिया हुआ क्वेश्चन में, देयर इज अ फिक्स्ड बाउंड्री थीटा इज इक्वल टू पाई बाय 6 एंड थीटा इज इक्वल टू माइनस पाई बाय 6. ओके, इन अ टू डायमेंशनल लिक्विड मोशन सोर्स एट ए पॉइंट आर इज इक्वल टू सी एंड सोर्स दिया हुआ है मतलब प्लस एम, एंड ए सिंक दिया हुआ है माइनस एम एट ऑरिजिन. तो ऑरिजिन पे क्या है, सिंक है, एंड एट पॉइंट आर इज इक्वल टू सी एंड थीटा इज इक्वल टू अल्फा वी हैव ए सोर्स. ओके, water absorbing at the same rate as sun. Find the stream function निकालना है and show that one of the stream line is a part of the curve this one. ठीक है, चलो देखो कैसे करेंगे इसको. So let us draw this plane. So we have this z plane and this is neta plane. Okay, so we have theta is equal to pi by 6 and minus pi by 6. So first boundary is at an angle of inclination of theta is equal to pi by 6, that is theta is 1, and theta 2 is equal to pi by 6. So this is first boundary and this is second boundary. ठीक है, and there is a source at r c comma alpha. Let us consider this point as this is c comma alpha, r is equal to c, or this is c alpha. So this point is like this. This is our source plus m. Okay, so now we have to do the transformation from z plane to the neta plane. So this is z plane, this is neta plane. ठीक है, so we are doing the transformation through here to from z plane to the neta plane using the function neta is equal to f of z. f कैसे आता है? f is given by z to neta is equal to z to the power n. So let us find the n. n की वैल्यू क्या होगी? n is equal to pi by 2 upon half of angle between the boundaries. तो pi by 6 plus pi by 6. ठीक है, this gets cancelled, this is 3. So we have this as 3 is equal to z to the power 3. So we have neta is equal to z to the power 3. So let us consider this as r e to the power I theta. So we have r cube e to the power I of 3 theta. This is capital R e to the power I 3 phi. Sorry, phi. Okay, so we have r is equal to r cube and phi is equal to 3 theta. ठीक है, तो let us draw that table for the transformation. So we have z plane, neta plane. Okay, we have theta 1 as pi by 6, theta 2 is equal to pi by 6, or this point is c comma alpha and source is plus m. So this is phi 1. So phi 1 is the angle of inclination of boundary 1 in the neta plane with respect to the horizontal. So 3 of theta 1. So this is pi by 2, और phi 2 is equal to 3 theta of theta 2. 3 times of theta 2 क्या हो जाएगा? pi by 2, और c अल्फा है तो यहाँ पे r इज इक्वल टू स्मॉल r का क्यूब, तो ये c क्यूब हो जाएगा, और एंगल में कैसे चेंज होता है? 3 टाइम्स हो जाता है, तो 3 अल्फा. ठीक है, तो दिस पॉइंट gets transformed into c क्यूब और 3 अल्फा. c क्यूब और 3 अल्फा. ठीक है, and we have this as pi by 2 and pi by 2. So this is pi by 2 and this is pi by 2. समझ में आ रहा है? So this is our so our point is like this. ठीक है, this is 3 alpha and this whole boundary is at pi by 2. समझ में आ रहा है? So let us draw this image of this. So this is our boundary, because the boundary 1 is at angle of pi by 2 with the horizontal, and boundary 2 is at pi by 2 in the negative direction. समझ में आ रहा है? This is positive y-axis is the boundary 1, positive, and negative y-axis is the boundary 2. So this is boundary 2, this is boundary 1. So image will lie in this side. Okay, so this is source. So what we have seen in the method of images is that for removing the boundary we put a equal source of equal magnitude. Okay, equal source of equal magnitude in the opposite direction of the boundary. So we have to work on the neta plane. So let us rub this. This is not required now. So this boundary will lie like this. So this is c cube comma 3 alpha. The boundary will, so the image will lie here. Okay, so this is c cube और ये एंगल कितना हो जाएगा? दिस इज 3 अल्फा, दिस इज 3 अल्फा, तो दिस इज पाई माइनस 3 अल्फा, तो दिस इज पाई माइनस 3 अल्फा. ठीक है, तो दिस इज प्लस m, दिस इज ऑल्सो प्लस m, and also there is a sink at origin. So this is sink at origin minus m initially, and by the method of images, so equal sink और add करना पड़ेगा ना. origin का जो image होगा वो origin पे ही होगा, because this point is at a distance, because in case of c cube 3 alpha, this point is at a distance of c cube. and it is at an angle of 3 alpha, so image will lie in the second quadrant. Okay, but the sink is at origin, so image will lie itself at the origin. Okay, so let us write down the complex potential with the system of images. So we have the system of images. System of images is, देखो पहला क्या है तुम्हारे पास, equivalent image system is source. Let us name this as Z1, this is Z2, and this is origin. So let us do this. So source plus m at c cube 3 alpha, ठीक है, at Z1 that is c cube 3 alpha. दूसरा this one source plus m at Z2 c cube और pi minus 3 alpha, and तीसरा sink minus m at origin, ठीक है. दिस वाज एज पर द ओरिजिनल कंडीशन. ओके, एंड और इमेज इसका, जैसे इसका इमेज आएगा तो वो भी वहीं पे आएगा ना, सिंक माइनस एम एट ऑरिजिन. ओके, तो दिस इज इमेज एंड दिस इज इमेज. ओके, दिस वाज आवर ओरिजिनल पॉइंट्स, and after removal of boundary this is image and this is also a image. Okay, so this is our equivalent image system. Okay, so let us write down the complex potential. So complex potential is W is equal to, पहले ये वाला तो क्या होगा, माइनस एम लॉग नीटा माइनस, लेट अस कंसिडर ए पॉइंट हेयर ए नीटा P. So complex potential at P नीटा is equal by माइनस एम लॉग नीटा माइनस Z1 और इसका माइनस एम लॉग नीटा माइनस Z2, ठीक है. और ये देखो ये माइनस एम तो 2m हो जाएगा, 2m लॉग नीटा माइनस ऑरिजिन पे है तो 0 हो जाएगा. समझ में आ रहा है? तो दिस इज लाइक दिस. तो W इज इक्वल टू माइनस एम लॉग नीटा माइनस Z1 की वैल्यू क्या हो जाएगी, देखो Z1 इज इक्वल टू R e टू द पावर I थीटा, तो दिस होल डिस्टेंस इज C क्यूब e टू द पावर I और एंगल क्या है 3 अल्फा. समझ में आना. और Z2 कैसे हो जाएगा, Z2 इज इक्वल टू R क्यूब, तो हिज होल डिस्टेंस इज C क्यूब, तो C क्यूब इंटू e टू द पावर I पाई माइनस 3 अल्फा, तो ये जाएगा Z2 इज इक्वल टू C क्यूब e टू द पावर I ऑफ पाई इंटू ई टू द पावर ऑफ माइनस आई इंटू 3 अल्फा. तो ई टू द पावर आई पाई क्या हो जाएगा, कॉस पाई प्लस आई ऑफ साइन पाई, तो ये तो 0 हो गया और ये -1, तो ये -1 हो गया ये. तो Z2 इज इक्वल टू माइनस सी क्यूब ई टू द पावर माइनस आई 3 अल्फा, ठीक है. तो ये आ जाएगा तुम्हारा. और नीटा की वैल्यू क्या आई थी, नीटा इज इक्वल टू जेड स्क्वायर आता है ना, क्योंकि एन की वैल्यू 2 आई थी मेरे पास, तो ये हो जाएगा तुम्हारे पास जेड स्क्वायर माइनस Z1 की वैल्यू सी क्यूब ई टू द पावर आई 3 अल्फा माइनस एम लॉग नीटा इज इक्वल टू जेड स्क्वायर और Z2 की वैल्यू माइनस सी क्यूब, तो ये जगह प्लस सी क्यूब ई टू द पावर माइनस आई 3 अल्फा प्लस 2m लॉग ऑफ जेड स्क्वायर, ठीक है. सॉरी, दिस इज जेड क्यूब एक्चुअली, n इज इक्वल टू 3 आया था ना, दिस इज 3, ठीक है. सो वी हैव W इज इक्वल टू माइनस एम लॉग ऑफ जेड क्यूब माइनस सी क्यूब ई टू द पावर आई 3 अल्फा इंटू जेड क्यूब प्लस सी क्यूब ई टू द पावर माइनस आई 3 अल्फा प्लस एम लॉग Z6, ठीक है. W इज इक्वल टू माइनस एम लॉग ऑफ Z6 और ये जगह प्लस जेड क्यूब सी क्यूब ई टू द पावर माइनस आई 3 अल्फा और यहाँ से आ जाएगा माइनस ई टू द पावर आई 3 अल्फा, ठीक है, दिस वन. और उसके बाद सी क्यूब और ये और दिस सी क्यूब ई टू द पावर आई 3 अल्फा और ई टू द पावर माइनस आई, तो ये कैंसिल हो जाएगा, तो माइनस C6, ठीक है, प्लस m log Z6, ठीक है। अब देखो ये क्या होगा, ई टू द पावर माइनस आई 3 अल्फा और माइनस ई टू द पावर आई 3 अल्फा, तो ये हो जाएगा, ये क्या हो जाएगा, ई टू द पावर माइनस आई 3 अल्फा और माइनस ई टू द पावर आई 3 अल्फा, तो ये हो जाएगा cos 3 अल्फा माइनस आई साइन 3 अल्फा, ठीक है, माइनस cos 3 अल्फा प्लस आई साइन 3 अल्फा, तो ये कैंसिल हो जाएगा, तो ये हो जाएगा माइनस 2i साइन 3 अल्फा, तो ये हो जाएगा माइनस 2i साइन 3 अल्फा, माइनस 2i साइन, ठीक है। लेट अस फर्दर सिंप्लीफाई दिस। So we have the complex potential as minus m log Z6 minus C6 minus 2i Z cube C cube sin 3 alpha plus m log of Z6. So we have W is equal to minus m log of Z6 minus C6 minus 2i Z cube C cube sin 3 alpha upon Z6. Okay, so we have W is equal to minus m log of 1 minus C6 Z minus 6 minus 2i Z minus 3 C cube sin 3 alpha. Okay, so let us put Z is equal to R e to the power I theta. So W is equal to minus m log of 1 minus C6 R minus 6 e to the power minus 6 I theta minus 2i R minus 3 e to the power minus 3 I theta C cube sin 3 alpha. Okay, so this is our the complex potential. So we have W is equal to minus m log 1 minus C6 R minus 6. Let us put e to the power minus 6 I theta. This is cos of 6 theta, cos of 6 theta minus I sin 6 theta. Okay, और माइनस 2i r माइनस 3 C क्यूब साइन 3 थीटा, sorry, this is e to the power minus I theta, this is cos of 3 theta minus I of sin 3 theta, and this is sin 3 alpha. Okay, so let us bifurcate the real part as well as imaginary part. Okay, so we have the complex potential as velocity potential plus I time of stream function. So on bifurcating the real part as well as the imaginary part, we will get the velocity potential as well as the stream function. So let us bifurcate this as, so we have complex potential phi plus I of stream function, okay, is equal to minus m log 1 minus, so let us write down the real part. This is C6 R minus 6 times of cos 6 theta. Okay, and from here 2i or this is I, so we have plus 2i square, मतलब minus 2 R minus 3 C cube sin 3 theta sin 3 alpha. Okay, so this is real part plus I, so this is plus I C6 R minus 6 sin 6 theta or from here we have minus 2i R minus 3 C cube cos 3 theta sin 3 alpha. Okay, so this whole term is the, so we have this as real part and this is imaginary part, this is real part and this is imaginary part. So how we will find the stream function? So this is stream function. So psi is equal to minus m tan inverse of imaginary part upon real part. This will be our stream function, and this one phi is equal to minus m of half log I square plus r square plus I square, I square. Okay, so this is not required in the, this is not asked in the question. We are being asked the stream function. Okay, so let us calculate this. So we have the stream function as minus m tan inverse of imaginary part. So this is c6 r minus 6 sin 6 theta. We can write it as 2 sin 3 theta cos of 3 theta. Okay, minus, this is not I here, this is I we have taken outside. So 2r minus 3 c cube cos 3 theta sin 3 alpha. Okay, upon 1 minus c6 r minus 6 cos of 6 theta minus 2 r minus 3 c cube sin 3 theta sin 3 alpha. Okay, this is our required stream function. Okay, is the stream function, Okay, what is being asked in the second part of the question is, one of the streamline is a part of the curve. Okay, so how we will get the streamline? The streamline is by equating the stream function to a constant, we get the streamline. So let us find the stream function corresponding, let us find the streamlines corresponding to the stream function. Okay, psi is equal to 0. So let us equate the stream function to a 0 for getting the one of the streamline. Okay, so let us see what is the streamline corresponding to the psi is equal to 0. So let us put psi is equal to 0. तो इससे क्या आएगा? This whole term will be 0. This means the numerator part will be 0. So we have 2c6 r minus 6 sin 3 theta cos of 3 theta minus 2r minus 3 c cube cos 3 theta sin 3 alpha is equal to 0. So cos 3 theta gets cancelled. Okay, so we have this as 2 and 2 gets cancelled. So we have r minus 6 and this is r minus 3. So we have r cube, or this one is, sorry, this is c6. So we have if we divide this by c cube, so we have c3 sin of c cube sin 3 theta is equal to, take this to the RHS. So we have this as r cube sin 3 alpha. Okay, so this is the streamline corresponding to psi is equal to 0. ठीक है, तो ये लिखा ना, one of the streamline is the part of this curve given by this one. Okay, so we have discussed the question number 3. So let us discuss question number 4. Okay, so let us move further. So what is given in the question is that between the fixed boundaries theta is equal to pi by 4 and theta is equal to minus pi by 4, there is a two-dimensional liquid motion due to a source of strength plus m at point. The point is given is r a comma 0. At a comma 0 we have a source of strength plus m, and at r is equal to b comma 0 we have a sink of strength minus m. Okay, so that the stream function. So we have to find the stream function and the complex velocity. How we will get the complex velocity? Complex velocity is given by dw upon dz come mod. On taking the mod, we get the value of the complex. We have the value of the complex velocity. Okay, so let us solve this question. So we have two fixed boundaries. So we have the fixed boundaries like this. This is our plane. Okay, so this is Z plane and this is neta plane. So we have been given the boundaries as theta is equal to pi by 4 and theta is equal to minus pi by 4. So this is our boundary. This is theta is equal to pi by 4, theta 1, theta 2 is equal to minus pi by 4. So we have these boundaries, boundary 1 or boundary 2. Okay, so and we have a source at point a comma 0. This is a comma 0 and sink at b comma 0. So this is plus m and this is minus m. Okay, so let us find the value of n. So we have the transformation from z plane to the neta plane, and this transformation is being governed by an expression that is given by neta is equal to z to the power n, where n is equal to pi by 2 upon half of angle between the boundaries, theta 1 plus theta 2. So theta 1 and theta 2 is pi by 4 and pi by 4. So let us calculate the value of this n. So we have this as pi by 4 plus pi by 4. So this gets cancelled, this value is 2. So the transformation is being done using neta is equal to z to the power square. Okay, so let us put z is equal to r e to the power I theta. So neta is equal to r e to the power I theta ka whole square. This is r square e to the power I 2 theta. Neta is equal to, this is capital R e to the power I of phi. Neta is equal to, so r is equal to r square and phi is equal to 2 theta. Clear हो रहा है? So let us construct the table, transformation table. So we have this as z plane and neta plane. So if we have z plane and neta plane, so we have theta 1 is equal to pi by 4, theta 2 is equal to minus pi by 4, and coordinate as a comma 0 or b comma 0. ठीक है? So we have phi 1. So phi 1 is the angle of inclination of boundary 1 in the neta plane with respect to the horizontal. So phi 1 is equal to 2 times of theta. So 2 times of theta 1 is equal to pi by 2, and phi 1 and phi 2. Phi 2 is equal to 2 times of theta 2 is equal to pi by 2 minus, and a square a comma 0 and b comma 0. So we have r is equal to r square. So this is cube of that value. So this is a square comma 0 and b square comma 0. So let us draw the boundaries in the neta plane. So we have boundary at pi by 2. So this is boundary 1 at an angle of pi by 2 and boundary 2 at an angle of minus pi by 2. Okay, and we have the sources at a square comma 0. So we have sources at a square comma 0 and this is b square comma 0. And we have seen in the previous lecture that the strength of the source, sink and the doublet remains same. It is independent of the conformal transformation that we are doing. So this value and this minus m will remain same. This will plus m, this is minus m. Okay, so this is our boundary. So let us draw the image of this a comma 0 and b comma 0. So image will lie in the negative side of the x-axis. So this is a square comma 0. So we have, by method of images, if we want to remove this boundary, we have to put an equal source and an equal sink at an equal distance from this boundary on the opposite side of that boundary. So this is a square comma 0, this is minus a square comma 0, and this is b square 0, this is minus b square comma 0. Okay, so this is plus m and this is minus m. So this is the equivalent image system. Okay, so equivalent image system consists of a point, let us source at a square comma 0, a sink at b square comma 0, and we have a source at minus a square comma 0 and a sink at minus b square comma 0. So we have the equivalent image system as source plus m at, there is no source and sink at origin. Let us check that. Okay, there is no source or a sink at origin. Okay, so let us consider this point as Z1, this is Z2, this is Z3, this is Z4. Okay, so we have source plus m at Z1, a square comma 0. दूसरा sink minus m at Z2, b square comma 0. Third, we have source plus m at Z3 minus a square comma 0, and we have sink minus m at Z4 minus b square comma 0. समझ में आ रहा है? तो let us write down the complex potential with whole system of these images. Okay, whole system of these sources and sink and corresponding images. Okay, to be very frank. So let us find the complex potential at point P. Okay, so let us find this. So the complex potential is given by minus Z1, so minus m log neta minus this a square. Okay, so Z1 we will write as Z1 is equal to a square plus I of 0. So this is a square. Z2 is equal to b square plus I of 0. Z3 is equal to minus a square plus I of 0, because there is no y component. Okay, so Z4 is equal to minus b square plus I of 0. So this is minus corresponding to this Z1. Okay, plus for sink this is plus m log of neta minus b square. Okay, now for Z3 this is minus m log neta minus neta plus a square, and this is minus m, तो plus m log of neta plus b square. ठीक है, तो this will be like this. So w is equal to minus m log neta square minus neta minus a square neta plus a square, तो minus a4 plus m log of neta square minus b4. ठीक है, तो let us write down the neta is equal to z to the power square. Let us put this value. So w is equal to minus m log z4 minus a4, because neta is z square, so neta square will be z4 plus m of log of z4 minus b4. Okay, so this is the complex potential. So let us further simplify this. So this is not required now. So we have w is equal to minus m log z4 minus a4 plus m log of z4 minus b4. Okay, so let us put z as r e to the power I theta. So let us write down this like here. So w is equal to, this will use later on. Okay, this expression we will use later on. So write down here, w is equal to minus m log of z4 minus a4 plus m log z4 minus b4. For finding the complex velocity, we will use that expression. Okay. So let us put z as r e to the power I theta. Okay. So we have w is equal to minus m log of r4 e to the power I of 4 theta minus a4 plus m log of r4 e to the power I 4 theta minus b4. So we have w is equal to minus m log of r4 cos 4 theta plus I of sin 4 theta. Okay, minus a4 plus m log of r4 cos 4 theta plus I sin 4 theta minus b4. Okay, so we have this as W is equal to minus m log of, let us write the real part and imaginary part separately. So r4 cos 4 theta minus a4 plus I of r4 sin 4 theta. Okay, so plus m log of r4 cos 4 theta minus b4 plus I of r4 sin 4 theta. Okay, clear hai? So how we will find the complex, how we will find the stream function? So by separating the real part and the imaginary part, we will get the stream function. And how we get the stream function? Tan inverse of imaginary part upon real part. So this is psi is equal to minus m log of, this log will not be required, this is tan inverse of, this is r4 sin 4 theta upon r4 cos 4 theta minus a4. Okay, plus m of tan inverse of, this is imaginary part, so r4 sin 4 theta upon r4 cos 4 theta minus b4. Okay, so let us take m common, so this is minus. Okay, so we have the formula tan inverse of tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. Okay, so let us use this. So we have psi is equal to minus m tan inverse r4 sin 4 theta upon r4 cos 4 theta minus a4 minus r4 sin 4 theta upon r4 cos 4 theta minus b4 upon 1 plus r4 sin 4 theta into r4 sin 4 theta upon 1 plus this into this. So this is r4 cos 4 theta minus a4 into r4 cos 4 theta minus b4. Let us simplify this. So we have psi as is equal to minus m. We have psi as minus m tan inverse. So this is देखो, this is r4 sin 4 theta into r4 cos 4 theta. This is r8 sin 4 theta into cos 4 theta, and this is r8 sin 4 theta into cos 4 theta. This will get cancelled. So okay, so what will be left like this, r4 sin 4 theta into minus b4, and this is r4 a4 sin 4 theta. So this is r4 a4 sin 4 theta, and this will be minus r4 b4 sin 4 theta. Okay, sin 4 theta upon, and this multiplication of this and multiplication of this expression and this expression gets cancelled. Okay, from numerator and denominator, and now we have this r8 sin square 4 theta, and from here r8 cos square 4 theta. So sin square 4 theta and cos square 4 theta will be 1. So we have r8, and from here this is r4 into a4 plus b4. So minus r4 a4 plus b4 into cos 4 theta, cos of 4 theta, and this is a4 or this is b4, तो plus a4 b4. ठीक है, and we will take r4 common, तो r4 into a4 minus b4, तो r4 into a4 minus b4, r4 into a4 minus b4, and this is sin 4 theta, sine 4 theta. So this is our expression for the stream function. This is same as what is being given in the question. This is R4 into A4 minus B4 into sine 4 theta upon R8 minus R4 A4 plus B4 cos 4 theta upon A4 plus A4 B4. Okay, let us find the second part of this question, that is velocity at point R theta. So the velocity, so we have the complex potential is minus m log of Z4 minus A4 plus m log of Z4 minus B4. Okay, so let us put Z as R e to the power I theta. So W is equal to, no, let us find dW upon dz, sorry. dW upon dz is equal to minus m into 1 upon Z4 minus A4 into 4z cube plus m into 1 upon Z4 minus B4 into 4z cube. Okay, so we have this as 4mz cube, sorry, this is minus 4mz cube, 1 upon Z4 minus A4 minus 1 upon Z4 minus B4. Okay, so we have this as, so this is minus 4mz cube Z4 minus B4 minus Z4 plus A4 upon Z4 minus A4 into Z4 minus B4. Okay, so we have this gets cancelled. So this is dW upon dz. So dW upon dz is equal to minus 4mz cube into A4 minus B4 upon Z4 minus A4 into Z4 minus B4. So we have the complex velocity as mod of this value. The Q is equal to mod of dW upon dz. So this is mod of this whole term. So this is minus 4mz cube A4 minus B4 upon Z4 minus A4 into Z4 minus B4. Mod of this whole value. So let us further simplify this. So this is Q is equal to 4m A4 minus B4 into Z cube ka mod upon, this is, let us put this as Z is equal to R e to the power I theta. So R cube e to the power I 3 theta. And this is R4 e to the power I 4 theta minus A4 ka mod into mod of R4 e to the power I 4 theta minus B4 का mod, ठीक है, and this is whole mod. So we have 4m A4 minus B4 into R cube cos of 3 theta plus I sin 3 theta का whole mod upon this is R4 cos 4 theta plus I sin 4 theta minus A4, this is mod, or R4 cos 4 theta plus I of sin 4 theta minus B4, this is whole mod. Let us further simplify this. So if we have this cos squared 3 theta plus sin squared 3 theta, this is one mod of this value. So we have this as 4m A4 minus B4 into R cube upon, this is, let us write down the real part and imaginary part as separately. Okay, so R4 cos 4 theta minus A4 plus I of R4 sin 4 theta, ठीक है, this is mod plus, sorry, mod of R4 cos 4 theta minus B4 or plus I of R4 sin 4 theta mod. So mod of this value is real part square plus imaginary part square का under root. This similarly for this one. So we have this as 4m A4 minus B4 into R cube upon we have this as this is r8 cos square 4 theta a minus b ka whole square. So this is square and this is square. So this is r to the power 8. So r to the power 8 minus 2ab. So 2 times of r4 cos 4 r4 a4 cos 4 theta. Okay, plus a to the power 8 whole 1 by 2. Similarly, this is r8, this is r8 cos square 4 theta, this is r8 sin square 4 theta. So this will be r8 minus 2ab. So 2 of r4 b4 cos 4 theta और ये b8 plus b8, this is half. Okay, so this is the expression for the velocity. So let us match this. This is 4m r4 a4 minus b4 r cube, and this is r8 minus 2 a4 r4 cos 4 theta plus a8, and r8 minus 2 b4 r4 cos 4 theta plus b8 ka whole square. So this is the required velocity at point, is the required velocity at point r theta. Okay, so we have discussed the conformal transformation in detail, and also we have discussed 2 important questions on this topic. So इसके आगे का हम लोग नेक्स्ट लेक्चर में देखेंगे. ओके, थैंक यू.